Solving absolute value equations. We are going to skip that step there at the top. We're just going to jump right into the steps to solve the absolute value equations. So step number one, first and foremost, you always want to isolate the absolute value expression. So isolate means you want to get something completely by itself. Think about isolation. If you're isolated from people, you're not with a bunch of other people, you're by yourself. So that's what we're talking about here. We're going to isolate the absolute value expression. After we do that, we create two cases. There are two scenarios. We're going to set the inside, and by inside we mean what's inside those absolute value bars, equal to both the positive and the negative value of the number on the other side of the equal sign. Solve both equations, and then we are, last but not least, going to check our solutions. We always want to check those solutions. Now, the step there specifically says extraneous solution. So extraneous, probably a new word for you. Extraneous solutions are answers that, when plugged back in, into the original equation, don't work. They don't work when we plug them back into the original equation. Excuse me. So let's look at a couple of examples here so you know what in the world I am talking about with these steps. So it's labeled number 3, but it's the first problem that we're going to do. We've got the absolute value of x minus 9 is equal to 5. If we look at our steps, step 1 says isolate the absolute value expression. Well, that absolute value expression is isolated. There's nothing in front of it. There's nothing after it. It's just the absolute value there on that side by itself. So step number 1 does not apply to this problem. So we go to step number 2, create two cases. Now I always, I just make a little like upside down V so I can separate what I'm looking at here. And it says you set the inside of the absolute value bars disappear. You set it equal to both the positive number of what's on the other side, so x minus 9 is equal to 5, and you set it equal to the negative value of what's on the other side. Notice I did not change what was inside my absolute value bars. It's x minus 9 in both cases, but one of them is positive 5, one of them is negative 5. Now we just have basic linear equations. We want to solve those. So we want to get x by itself. We add 9. Negative 9 plus 9 is 0. That goes away. 5 plus 9 is 14. So x equals 14 is one of our potential solutions. Solve the other one. We do the same thing. We add 9 there. We get x is equal to 4 in this case because negative 5 plus 9 is 4. Now, before you box in your answers and say that these are the absolute correct final answers, you always check them. Always, always, always. So the absolute value in your calculator, there are a couple of ways to get there, but really the easiest way to do it is second 0, and it's the very first option. Okay, let me do that again. Second 0, and it's the very, very first option. ABS, it stands for absolute value. Okay, it's not, there's not a vertical line there on your calculator for the absolute value. So we want to check 14 as our answer. We get 5, and then we also want to check 4 as our answer, and we also get 5. Notice I'm plugging it back into the original equation, okay, and making sure that in both cases I get 5 for my answer. So I got 5 in both cases, so 14 and 4 are both solutions to that equation. All right, let's look at number 5. Let's look at number 5. We're going to skip number 4 for the moment. Let's look at number 5. The absolute value of y minus 1 plus 17 is equal to 23. Here's a case where we use step number 1 to isolate the absolute value. It's got a plus 17 after it. We are going to start by moving that 17 to the other side by subtracting. So we've got the absolute value of y minus 1 is equal to 23 minus 17 is 6. You'll find that I don't use the calculator a whole lot for computations like that. I absolutely encourage you to do so. I just try and keep my mental math skills sharp, okay? All right, so we've isolated it. So now we create our 2 scenarios, our 2 cases. Y minus 1 is equal to positive 6. Y minus 1 is equal to negative 6. Solve them individually. Add 1, so y is equal to 7. Add 1, so y is equal to negative 5. And check it. Every single time you check it. Now, when you check it, you go back to the original. The absolute value of, let's check 7 first. 7 minus 1, you got to close the parentheses. After the 1, you put the parentheses in the place of the absolute value bar. Plus 17, that gives us 23. Let's check negative 5. Negative 5 minus 1, close the parentheses, plus 17. And we get 23. So both of those gave us the number that we were supposed to get. So both of those are the solution to this equation. Let's look at number 6. Number 6 is similar to number 5, but we are multiplying that by 3. So our first step, those absolute value bars are not like parentheses, okay? You cannot just distribute the 3 in there. You need to start by doing the opposite of multiplication, which is division. So we've got the absolute value of m plus 18 is equal to 39 divided by 3 is 13. So we're multiplying the absolute value by 3. The opposite is to divide. So we divide both sides by 3. Our absolute value is by itself. So now we set our 2 cases up. M plus 8 is equal to 13. M plus 8 is equal to negative 13. Solve them individually. Subtract 8. 13 minus 8 is 5. Subtract 8. Negative 13 minus 8 is negative 21. Always check it. Go back to the original. So it's going to be 3 and then the absolute value of 5 plus 8. That gives us 39. Then 3, absolute value, negative 21 plus 8. That gets us 39. So both of those check out. We didn't run into an extraneous solution yet. That will come up on Monday, but for right now, all of our solutions have worked. Any questions about solving it algebraically before I show you solving it by graphing? Okay, so we're going to use number 5. This is the exact same problem that we just did in number 5, but I want to show you solving by graphing. The absolute value of y minus 1 plus 17 is equal to 23. So to solve by graphing, step number 1 is y equals the left side of the equation. And y equals the right side of the equation. Now, you've done solving by graphing before, not with absolute value, but you've done it with linear functions, you've done it with quadratic functions, you've done it with various functions. What you're always looking for if you're solving by graphing is you are looking for the intersection. Find the intersection of the 2 graphs. There will probably be two places. Probably be two intersections with these. Because all the answers that we've gotten so far, we've gotten two answers. So there will probably be two intersections that you're looking for. The x-coordinates are your answers. Now, in my opinion, I don't think it's too terribly hard to solve these by hand. Y'all didn't have any questions about it so far, solving it by hand. But I just want to give you as many tools as I can in the toolkit. So let me show you really quickly how this works. Now, in this case, y is in our equation. Obviously, we want to replace that with an x if we're actually graphing it. Okay, replace y was in the equation, y was the variable in the equation. Just replace that with an x. So we've got y equals the left side of the equation, y equals the right side of the equation. Now, it looks like I don't see anything. If I zoom out, if you don't see anything, definitely make sure that you zoom out. Because for these graphs, like y equals 23, with the y value of 23, it's way up here. That was not in my standard viewing window. Our absolute value function is also outside of the standard viewing window. So you can see the two graphs right here. Here's the y equals 23, the horizontal line. Here's the absolute value function. We just graphed those a little while ago. You're used to what that looks like. All you have to do in Desmos is click on either one of those lines, and those intersection points show up right there. You just have to click on them to get their coordinates. And notice, what are the answers? -5 and +7. That's what we got when we solved this one by hand. We got -5 and +7. So I'm just showing you there's another tool in the toolkit for solving any type of, this works for any type of equation, y'all. I'm showing it to you specifically with absolute value equations, but it works for any kind of equation solved by graph. Any questions about what I did here in Desmos?